Hey y'all, Jeremiah from Hail Design Tech, and you're about to watch an air compressor rebuild video. It's not a restoration because I didn't reuse some of the parts. I'm rebuilding with new components. Before you start yelling at me in the comments saying how dangerous this is to rebuild an air compressor, yes, I know, and I'm just kind of crazy like that. But if you attempt to try anything like this yourself, be very careful and make sure your tank can handle the pressures you're going to be pumping up to. All right, let's go ahead and check out the build.
So I found this air compressor on OfferUp for about $100. I made an offer on it, see what they're gonna say. And it's an old beat up thing, but it looks to be about an 80 to 100 gallon. And quite old, it probably needs some restoration, but I think I can make something happen here.
Heading out to pick up this air compressor, and excited to get a first look at it because it's a beast. I got some help to pick it up, but I got another about 45 minutes out to get it. And I'll show you some video when I get there. Okay, picked her up. Very nice gentleman that was able to help us load it as well. Came with its own pallet, and it's a rusty beast, but the tank's gonna be nice and solid. This air compressor is gonna need some love. It's missing all the gauges and everything else on there, but you know, so this is my new project. So I got this big old thing home. Everything about this thing screams, fix me. She's got a little chip in the cooling fins. Janky. This looks okay, but the other side looks like it's been smashed. And generally rusty. A little attitude. But staying positive, aren't we? I gotta take it off now from the tank and move it over to my table to get her cleaned up, to see if it's salvageable. That's next. Got her off the tank and over here. That was a pretty good move. I didn't get any video of it because this is a critical move and I didn't want to, I wanted to focus. So you want to hear the bad news, Max? Bad news. Yeah, bad news, man. You got your own bad news. Okay, so the compressor is completely rusted out on the inside. Here are the piston heads. They are so rusted that the connecting rod snapped when I tried to take them off. So. And then the motor was so rusted it wouldn't come out of the crankshaft, so I had to cut it. So it's a little bit shorter now. But as far as I can tell, the motor is salvageable out of this. But the pump obviously is toast, and everything you see on the ground or on my welding bench here came out of the pump. So it was just, there was about that much, sand in the bottom of this thing. And absolutely no oil, bone dry. So I'm guessing this thing sat underwater for a little while. I bet you it fell over at one point and then fell into a lake. I don't know, but it was definitely full of water at one point. And these are all frozen up. So I'm gonna have to scrap this compressor, which I already did. And maybe this motor's salvageable. It's pretty clean on the inside once you get everything taken apart. So We'll see if we can salvage this and get another compressor. So I've got to replace this, it's called a check valve, and it only allows air to go in one way. And it's got a relief here so it doesn't store air on this side. This is where the pump feeds in, and it's easier to restart the pump if you drain this. And these things are like 30 to 50 bucks depending on where you can find them. And this is a pretty special one. It's a 3/4 MPT threading to FIPS, I think, maybe. 1/3 threading. This is the refrigeration compression fitting threading, and so that's what you use to connect to the pump. But this little guy, I think I'm going to try to salvage it, clean it up a wee bit, and take it all apart, see if there's anything working, and then maybe do some pressure tests and see if it'll actually hold pressure, so I don't have to buy another one. So this little operation should hopefully save me a couple bucks. There it goes. All right, snapped away. And I'm gonna call that a cleaned up check valve. Okay, it's a little grainy, but here's a shot of the inside of the tank. What you're seeing down there is the bottom. It looks like some water sat down there, and there is some rust buildup. Doesn't look too bad. Looks like there's a rust that goes down the side for some reason. So that looks like to be the rust that probably came in from an opening in the side there where it's sat open for a little while where you hook up the air hoses. So there's rust down that, but other than that, it looks okay. Okay, about a half a can on the bottom, and just got some spots like that. I'll have to grind out, paint over again, but doing pretty good. So it looks like this tank was made in Lynchfield, Kentucky. That's a 200 PSI model, and it was made in 1987. Pretty cool. I was able to save this vintage label part of it. Just put some masking tape over it when I painted it, and I was able to save this historical piece. 2, here's 3, and 4. Okay, so I got about a 1/2 inch clearance on this side. Looks like it'll work over here. And my motor's gonna mount somewhere around here, like so. And so I should have plenty of clearance to cut it right where I want to. Right about there. And that'll leave all I need to do to mount the motor right here in this about foot area. There'll be plenty of clearance for my motor. That'll do. Let's just get this cut. Okay, check out the craziness that I've concocted here. It probably void the warranty on my chop saw, and probably chop my arm off, and hopefully chop this in half. Feel free to roast me in the comments for the setup. I would probably roast somebody else if they tried something like this. But hey, desperation, you know. Get loud. Do in this janky setup. The rest will have to be cut with an angle biter. I mean an angle grinder. I'm not that crazy. All right, made some progress. Grounded down the plate that's going to go on here. Made myself a little spacer because it wasn't quite sitting level without it. So the next job is to weld this spacer to the base plate. It's a square thing here. So we'll get that welded on. And I also went through and cleaned it up with an angle grinder in the places where it's going to get welded to the tank. So this little square here will get welded to the top of this guy here, and then that other square will get welded to the top here. It's not exactly flat, so I can only weld one side of this, but should do the job just fine. Okay, let's get rolling here. Doing some TIG welding with some ER70S-2 16th inch filler wire. I didn't say filler, filler, not feeler. Filler. And I'll be running a TIG welder set on explode, turned up to 11. First I'll just do some quick cuts with filler and a test cut. That big metal don't want to melt it. Oh, 75 amps on that one. I think I'm going to go up to 80. Too much, this top plate will melt away. Too little, and it won't connect to the bottom. Oh, I almost want to preheat this. But no, I'm not that crazy. Save that for the pros. I'm just a YouTuber. Let's get going. Come on, baby. There you go. Oh, I blew out that corner. Dang it. And didn't really connect all that well over here. That base metal does not want to heat up. This is 060, so roughly at 1/16 of an inch. And this is 1/4 inch plate. So welding these two together, are going to be a task, that's for sure. Welds don't look too bad once I get going. So let's do the other side. There we go. I'm not the smoothest welder in the world, I'll tell you that for sure. Yeah, let me move you, hold on. Alright, let's see how this goes. I'll probably bump the camera a few times. It's straight up in my grill. But, let's go. I can do it. Oh, I'm rounding the corner for sure. Oh, it's bad. And you'll probably just see the back of my glove for this one, so sorry. Oh, stuck my tungsten. Damn it. And I'm still welding. Even worse. Okay, it's not structural. It is a little bit structural. I'm losing it too. Come on. Come on. There you go. Yeah, halfway through I literally stuck the tungsten, so. Don't do what I do. If you stick your tungsten, stop welding and go clean it. That's terrible welds. But hey, it'll hold. Guaranteed. Yeah, not the best. Kind of all over the place. But she'll do. Okay, got a weld in here. Then underneath over there, a little bit on this side, then this on the other side. Then we'll go over there and weld to that piece that you just saw me weld. We'll weld up, so it's over there. You can't see it, but it is. We gotta weld that last, because this plate might warp all over the place on me while I do this. Hopefully not, but it might. It's welding to a pressure vessel. Make sure you have an air hole opening. Even if you're not even welding directly to the tank, that's important. Okay, that's not going nowhere. And we'll just weld this out right here. Not the whole thing, just like an inch or two. And I'll weld the other side. Then I'll weld a little bit in the middle over here and then a little bit over there. The reason I do that is so it doesn't warp up on one side and I can't get the other side to sit flat. And I gotta do the walk of shame for my tungsten electrode. I stuck it in the last one, so I gotta grind it again. I will still be using 1/16 ER70 S-2 as my filler. Ground clamp. Okay, so yeah, welding might scare the average home gamer, especially TIG welding, which is what I'm doing. Usually you'll find home gamers doing MIG, which is the pull the trigger and let it go type welding. That's what it's a wire spool fed. A little easier, I would say. Well, it has its hard points, so I'm not gonna say the TIG's better. But TIG is like sewing with fire, so it might scare you off, but for some reason, it actually calms me down. I don't know why, but TIG, excuse me, man, that's a gap in there. TIG welding it is challenging, but it's also very rewarding when you can pull something off. I like it. Okay, here we go. That's lay wire technique. Looks like she worked. So it's going to be quite boring. It's going to be quite slow and monotonous going all the way across this. Plus I got to do a few setups. I got to go to the other side, lock that down, and tack. Usually do a few tack runs like this. So I'm not going to film everything. So I'll just show you my finished product. I'll bring you right back. Okay, got the flash back on. So that was the connection into this tie rod over here. Not my best weld. I tried, it's a 3-pass weld, so in, up, and then across the top, but I just put way too much filler on that last pass because things were getting hot. I shouldn't have tried 3 passes. I should have just done try to do like a weave or something, but hey, it's on there. It's not going nowhere. It'll hold. Okay, let's go for the other ones. Excuse me. So I was able to get up underneath this lip. I ended up having to do like a double weave pattern across. That seemed to start working out pretty well. Had to do a lot of stop and starts. All the way around, but it turned out pretty good as far as I can tell. I adjust my heat a few times and get the inner metronome going, but turned out pretty well. I'm happy with those welds. So you can see the stop and starts. Let's get closer. There we go. So stop too hot, turned it down a bit more, just right, then freaked out, turned it back up again, then turned it down and back up. Yeah, you know, that's the way it goes. You can see the weld history in the heat pattern, but for the most part it turned out pretty well. I'm happy with this. It'll definitely hold a motor and a pump. So found out about halfway through that I needed to be a wee bit taller, so threw an old toolbox down there, stand on, and got her done. Knocked her out. Call these up to 3/8. I need to ream them out there, knock off the burrs. But this cutting fluid works pretty well. Just need to give it time to cut, and I ended up using 3 step sizes because I was finding that the hole would walk a bit, going straight from a 1/8 to a 3/8. So I had to go through I think a 1/4 first, and then I think I threw in some odd one. What did I use? 23/64. But made it work. So the last bit was basically just reaming the hole out to size. They need to be cleaned up, but they'll do. Alright, so I put the bolts on, but I forgot to record that, sorry. But I didn't get the chance to put these lock washers on because the bolts are barely long enough just to get the nut on down there underneath. So I'm just going to crank them down, and if they give me problems, I'll look into upgrading my bolt sizes on here. But I think just cranking it down should be just fine. But she's mounted on there. Not going nowhere. Okay, it's time to fill the pump up with non-detergent compressor oil, specially formulated. So I lack my funnel. I have no idea where I put it. So I'm just going to go ahead and throw it in one of these science flasks and load it up that way. And then I can actually measure whether I'm getting my full 32 ounces you're promising me here. Should be somewhere around 190 or 940 milliliters. So should fill it up to right about there. I'll see if it does or not. Okay, the extra milliliters is just in the bottle, I guess. Pretty darn close to 32. Okay, we'll put this in the pump once that bottle drains out a little bit more. Okay, at level, oil should be right across that red dot there in the oil sight gauge. So we'll fill her up. I'm not quite exactly sure how much it's going to take, and it may even take even more than this, but I doubt it. But let's go ahead and put some in and see where I get. And the world's smallest little hole up here. It's not the world's smallest, but hey, be nice. I am really missing my funnel. This is going to take a while, so I'll cut back in a minute. Okay, looks like she took it all. And I'll need to have some more. Ugh. My smart butt only bought one bottle. But 32 ounces, and she's still not in the sight gauge yet. So, more compressor oil. 16 more fluid ounces. See how this goes. This actually does have a perfect fill cap, but I want to measure it anyway. Yes, my workbench is messy. Leave me alone. I'll get to it in a minute. So 16 fluid ounces should be roughly, head calculation, should be roughly that. And it is. Well, actually it should be around 430 milliliters. So it's a little over 16 ounces. Thank you, Cobalt. Not that I use any of our tools, I'm just the only kind of compressor fluid I could find on short notice. Okay, let's fill her up some more. So they painted the inside of the threads on this thing, so every time you take this off, it's getting better and better each time, but it's just nasty. I hate to see what the inside of this pump looks like. But if it's just paint flakes, it should be alright. More footage of oil going in places. Oh yes, the compressor's cheap, guys. Come buy it. Oh, by the way, you gotta spend an extra 20 bucks on fluid because we don't provide that. Yay. Alright, she took all of the extra 16 ounces. And I think we're good. So the oil level is right where it should be. Right across that red bubble. We'll give it a little while to adjust, but I think we're good. So the consensus is 48 fluid ounces. Fill this bad boy up. Fun, right? Man, this dog cannot be bothered. Just chilling. Okay, there's my goofy little swivel swish pipe. That's what I'm gonna call it. And I'm dangerously close to collapsing the pipe right here, so I didn't want to bend it anymore, without a, legit pipe bender. But I'll do a straight down, 90, 90, 90 in once I get a proper setup and a new pipe. But that'll work for now. And it looks kind of steampunk. I like it. I don't know about you, but I like to keep the dangerous things in front of me, so I can keep an eye on them. So in this case, in this compressor setup, the dangerous stuff is going to be the flywheel and the motor and the belt spinning. It'll be behind a cage, but I wanted to put the power switch and everything right here in front, so I could keep an eye on it. And the way it worked out best, to see the pressure gauge is mounted on the side like this. Mounting it down here, it's facing too low. Over here, I can just look over and see what the pressure is. So that works good. On and off switch is easy to reach. Pressure is going to be right here. It's going to blow off in that little hole right there, going that way, so the blow off doesn't blow right at you. The in power will go in here. The out will go out of here, make a hard 90, and go down and around to the motor over there. Once I get everything set up. But still waiting on a motor from the old Mails systems. It's going to be delivered by UPS. Still waiting on that, and then we'll get that mounted up when it gets here, and we'll get this thing kicked on. Okay, got the connections all wired up for the main in. It's overkill, but it leaves me headroom to upgrade later if I want to. Big old long cable. That will do for now. Not long at all, actually. It's only 6 foot. And then the motor wire will come in here and connect to there. And I got something for that. Let me show you. I'm a big fan of these flexible conduits, pre-assembled. Like we can use them for washer and dryers, ranges, anything that requires a good bit of current usually. I'm just hooking up appliances sometimes. So I grab these all the time. They're good in just about any environment, and they're cheap, and they're already pre-wired. It does a lot of the work for you. Okay, pulled it out of his bag here, but and also if it's too long, you can actually just cut wherever it needs to be cut down to, and just move this, take this nut on the end and pull it off and move it on down to wherever you need it to be. So these things are quite flexible, literally and figuratively speaking. So this will be my motor wire. Sorry, it's kind of sideways, but this little brass pin stick out here pushes against a needle at the bottom of this valve here. So when you flip it off, or when it automatically flips off, it goes up and releases any air pressure in this line. So this basically becomes an open valve when it switches off. And when it switches back on, then it closes the valve up again. Let's call it bleeder valve, and it just helps the pump restart. So it's not facing the full tank pressure as it tries to restart the motor and the pump, because the restarts are the hardest on the motor and the pump, I guess. I don't know if you can see that on camera or not, but that's where I'm going to cut it. I know they make smaller ones of these, but if you see my channel, I don't have anything that's small. Okay, freed it from the rest of the copper, and pulling it out like so. Then it'll just be a single bend. Around the bend into that angle, a little bit more. There we go. You should over bend by a couple degrees, because when it pull it off the bender, it changes his mind again and goes back to whatever it wants to do. Okay, looks like it popped off over there. All right, that looks pretty darn good right there, except for it's touching the top of my tank. And I don't like this sort of bend out and then around. So I'm gonna see if I can do something about that. So let's see if we can straighten this a wee bit. Okay, and then drop the angle down here by about 10 degrees. Okay. Like so. Not touching a darn thing. That's the way I like it. I think I overbent this U just a wee bit, but we can make that work. That looks professional, if I say so myself. What do you guys think? Look good? All right, let's get this tightened down. I'm gonna use compression fittings. With little compression rings and fittings, you don't need to use Teflon tape, but the side that goes into the blow-off valve here does need it. Okay, run it the same way as the threads are. People all say, no, you gotta put it on counterclockwise or clockwise or whatever. It's like, no, that's wrong. You put it on the direction that it screws in. That way it doesn't get all bunched up and get peeled off. Going in. Okay. So that goes on here. Okay. It's considerably a little shallower than it was before, so didn't account for that. Whoops. Hopefully I can get by. Put you back where you're supposed to be. Oh yeah, I'm totally fine. If your compression fittings come with these things, they're only needed for plastic style tubing. Compression ring inside the compression nut, like so. Then we'll put the nut on, loosey-goosey like, and then we'll work the pipe through the nut and the ring and all the way in. Okay. And the reason you do that is it just helps get everything aligned nice and neat. Make sure the pipe's in there. Then give her a few cracks and she'll be good to go. With the right size wrench. And this has the compression sleeve style. So this guy just goes up in there and just jams everything together. Okay, I'm gonna call that good. And then we'll do some leak tests on it. So I got this little 1 to 3, these are all 1/4 inch. And this is mainly for a 3/8 inch drive line coming in. But I actually just drilled and tapped it for a 1/2 inch MBT. I want this to cut out right at 130 PSI and cut back in at 90-ish PSI, somewhere around there. It'll be quite noisy, and shaky. I don't know how all this is going to work out, but we'll do what we can do. Let's get loud. Blow-off valve went at 115 PSI. That's lame. Cuts out at 130, starts at 85. So that's a good little window. Well, yeah, super happy. Got me a new fluid-filled gauge. The gauges I use for wiring this thing are overkill, so getting this back on is a bit of a chore. Feels like a brand spanking new unit. Now, what's all this fuss about? Okay, hold on. All right, bring it in. Let's see, where is it? There it is. Wow, that's powerful. Okay. Always gotta take the little cap off. There you go. Oh, and before I forget, in the video I don't have the air compressor bolted down yet, but by the time this airs, I do have the air compressor bolted down now. And it's got little rubber feet underneath it to cut down on some of the noise vibration. So, cool. Go ahead and subscribe if you like engineering, 3D printing, mechanical engineering, and building a micro fabrication job shop in your garage.